What if I told you that astronauts age slower than the rest of us? What if speeding up didn't just make your journey shorter, but actually slowed your experience of time itself? What if time, the very thing you set your watch by every day, is more fluid and personal than you ever imagined? It's not science fiction. This is time dilation, one of the strangest, most fascinating, and most misunderstood concepts in modern physics. It was predicted by Albert Einstein over a century ago, and today it's not just a theory, it's a measurable, real effect. So how does time dilation work? Who proved it? And what does it actually mean for you and me? Let's break it down. Time dilation is the idea that time doesn't pass at the same rate for everyone. It depends on your speed and the strength of the gravitational field you're in. There are two main kinds of time dilation: velocity-based time dilation from special relativity, gravity-based time dilation from general relativity. Let's start with the first one. In 1905, Albert Einstein proposed the theory of special relativity, and with it came a revolutionary idea. The speed of light is constant no matter how fast you're moving. To make this possible, space and time themselves must adjust. This means that the faster you move, the slower time passes for you compared to someone standing still. Here's a classic thought experiment. Imagine two identical twins. One stays on Earth, the other boards a spaceship traveling close to the speed of light, circles around, and comes back. When they reunite, the twin who stayed on Earth has aged more than the twin who traveled. This is called the twin paradox. And it's not just a weird idea, it's real. We've tested it. High-speed particles called muons, created by cosmic rays hitting Earth's atmosphere, should decay in microseconds, and they do. But when they're moving near the speed of light, they live longer. Why? Because from our perspective, their time is running slower. We've also confirmed this using atomic clocks on airplanes and satellites. They tick differently depending on how fast they're moving. So, yes, speed affects time. If you could somehow travel at 99.9999% the speed of light, you could live just a few months on your ship, while thousands of years pass on Earth. Then in 1915, Einstein upped the game. On Earth. As predicted by Einstein, the ones further from Earth's gravity ticked faster. Now take that idea to the extreme. Near a black hole, gravity is so strong that time can practically freeze. 1 hour for you near the event horizon could be 10,000 years for someone far away. This isn't just theoretical. Movies like Interstellar portrayed this idea beautifully, based on real physics advised by physicist Kip Thorne. And yeah, it messes with your brain. So let's get real for a second. Is time dilation just an abstract idea, or is it actually something we use? Turns out we rely on it every day. The best example? GPS satellites. These little guys orbit Earth at around 20,000 kilometers above the surface. Because they're moving quickly and they're further from Earth's gravity, both types of time dilation apply. Engineers must correct the satellite clocks by about 38 microseconds per day, or else your location on Google Maps would be off by kilometers. Then there's the Haffel-Keating experiment in 1971, where scientists flew atomic clocks on commercial airliners east and west around the globe. When they landed and compared the clocks to those that stayed still, they were different, exactly as Einstein predicted. So, what do the big brains of physics say? Albert Einstein himself was cautious but confident. Time is what a clock measures. But when he introduced these ideas, many physicists were skeptical. After all, these concepts were deeply counterintuitive. Later, Richard Feynman, Nobel Prize winner and legendary teacher, embraced time dilation fully. The strange thing about science is that it forces us to question our deepest assumptions, even time itself. Stephen Hawking often used time dilation to explain the nature of black holes and the event horizon. Time slows down near massive objects. If you could hover near a black hole, you'd see the universe race ahead without you. More recently, Greene, author of The Elegant Universe, calls time dilation a gateway drug to deeper understanding. Once you grasp how time bends and stretches, you start to see the universe differently. You start to ask better questions. All of this leads to a strange, beautiful question. What is time? We treat it like a river, always flowing in one direction. But the more physics we learn, the more it looks like a dimension, just like space. One we can move through at different rates depending on our motion and location. Einstein changed how we see the universe by showing that time is not absolute. Instead, it's personal. Your time is not my time, and neither of us sees time like a black hole does. In fact, one way to define reality is everything that shares your experience of time. Let that sink in. Let's play with some ideas. If you had a twin on Earth and you traveled close to the speed of light to another galaxy and came back, you could return to Earth millions of years in the future, while only a few years passed for you. If you lived near a black hole, your clock would move slower. You could theoretically see the distant future unfold while barely aging yourself. Technically, time travel to the future is possible. Time dilation is the key. Does that mean you could one day pause your own aging? Maybe. It's not just physics trivia. Time dilation matters because it shows us that reality is stranger than it appears. It also forces us to ask big questions. What is now? If my time is different from yours, whose time is real? Can we truly understand the universe without understanding time? And maybe most importantly, if time can stretch and bend, what does that say about how we live our lives? It's a wake-up call. A reminder that time is not guaranteed. It's flexible, yes, but it's also fragile. So here's the personal part. If time is personal, if it really ticks differently for everyone, then what you do with your time is everything. That moment you spent helping someone, it mattered. That hour you used to chase a dream, it was a rebellion against the void. That second you hesitated, maybe that was the start of something big. Don't just let time pass. Stretch it, use it, own it. Because the truth is, you're not stuck in time. You're surfing on it. And that is beautiful. Thanks for watching. Stay curious. Stay aware. And remember, the universe is weirder than we thought. And that's what makes it worth exploring. You made it all the way here. Brain spinning, questioning if time is even real. And you're still not subscribed? Look, this channel isn't just content. It's a mental roller coaster through black holes, brain glitches, and bizarre theories your school never dared to teach. If you're into stuff that blows your mind and makes you say, wait, what did I just watch? Then yeah, you belong here. Smash that subscribe button so we can decode the universe together. Or at least get really confused trying. And hit the bell too, because if time is fake, notifications better be real. Let's get lost in the weirdest questions of existence. One rabbit hole at a time.